Welcome back, everyone, to the deep dive. Ready to dive into the world of LLMs. Today, we're going to be looking at how they're trained and what this whole instruction tuning thing is all about. And, maybe we can even get a little peek behind the curtain to see how the AI magic happens.
Sounds exciting.
It is. And we've got a really fascinating research paper to help us explore all this.
Oh, yeah. What's it called?
It's called Smaller Language Models Are Better Instruction Evolvers.
Smaller language models are better instruction evolvers. That's a pretty bold statement.
It is right. It kind of makes you wonder, doesn't it? Because usually when we think AI, we think bigger is better, more data, more computing power, more impressive results.
Yeah, that's been the prevailing assumption for a while now, for sure.
Right. So this whole idea that smaller language models, SLMs, could actually be better at something as important as creating instructions for LLMs,
Yeah,
it's definitely a bit of a head scratcher, right?
definitely.
So before we get too far ahead of ourselves, let's make sure we're all on the same page here. What exactly is instruction tuning?
Well, think of it like giving an LLM a really detailed set of instructions, almost like a recipe, so it knows how to carry out a specific task. And the clearer and more precise the instructions are, the better that LLM is going to perform.
Okay, so it's like we're teaching the AI to cook, but instead of delicious meals, we're getting insightful outputs.
Exactly.
But here's what I don't get. If instruction tuning is all about giving these crystal clear instructions, wouldn't a larger, more complex LLM be better at understanding and executing those instructions? I mean, they have more knowledge, they have more processing power.
Well, that's where this research really challenges our assumptions. It turns out that when it comes to creating these instructions, smaller language models, they might actually have a surprising advantage.
It's almost like saying that a home cook can write a better recipe than a Michelin star chef. I mean, is that a fair comparison?
It's an interesting analogy, and there might be some truth to that. You see a chef with access to every ingredient imaginable. They might overthink a simple recipe, but a home cook working with limited ingredients has to get creative and resourceful.
So you're saying that because SLMs have less computational power, they're actually forced to be more inventive with the instructions they create.
Exactly. They have to be more strategic and precise with their language to get the desired outcome. And the researchers found that this constraint actually leads SLMs to generate a much wider variety of instructions, instructions that are more nuanced and less predictable than those produced by larger LLMs.
So wait, are we saying that limitations can actually breed creativity? I mean, it makes sense when you think about it. Sometimes having too many choices can be paralyzing, but I have to admit I'm still a little skeptical.
Well, that's understandable. It is a counterintuitive idea. But the researchers do provide some pretty compelling evidence to support this claim. They actually analyzed what's called the token probability distributions of the outputs generated by both SLMs and LLMs.
Okay, before we go any further, can we maybe break that down a little bit? Token probability distributions sounds a bit intimidating.
Oh, it's actually simpler than it sounds. Just imagine that the language model is trying to choose the next word in a sentence right. There are tons of words to choose from, each one with a certain probability of being selected based on the context. So this token probability distribution is basically a map of how likely the model is to pick each word.
Okay, so it's like a roadmap of the model's decision-making process. What did the researchers find when they looked at these roadmaps?
They found a striking difference between the SLMs and the LLMs. Larger models, with their vast vocabulary and complex algorithms, tended to have very concentrated distributions, meaning they relied really heavily on familiar patterns and produced very predictable outputs.
So they were sticking to the well-trodden path, playing it safe.
Exactly. But the SLMs, on the other hand, they showed much broader probability distributions. They were much more willing to explore a wider range of words and phrases, even unconventional ones. And this suggests that they were generating more diverse and creative instructions that LLMs might not even consider.
So it's almost like the SLMs are thinking outside the box while the LLMs are stuck in their comfort zones. But how can we be sure that these more creative, these outside the box instructions are actually better? Novelty doesn't necessarily mean effectiveness, right?
You're absolutely right. And to address that, the researchers put these instructions to the test. In a series of experiments across various tasks, they compared how well LLMs performed when they were following instructions generated by SLMs versus instructions created by other LLMs.
And what were the results? Did the SLM-generated instructions actually lead to better performance?
This is where it gets really interesting. The results were pretty consistent across a wide range of tasks, from instruction following and question answering to math reasoning, even code generation. LLMs actually performed better when they were given instructions crafted by those smaller, more creative language models.
Wow, so the evidence really does seem to back up their claim. But I'm still curious about why this is the case. What is it about SLMs that gives them this advantage in instruction creation? Is it just about limited resources forcing them to be more creative? Or is there something deeper at play?
That's a great question. And the researchers have a fascinating theory. They believe it has to do with how these different models approach language itself. Think of it this way. Larger language models with their vast knowledge and complex algorithms are like seasoned writers. They've got huge vocabularies, a deep understanding of grammar and style, and a tendency to stick to those tried and true techniques. They might be good, but they're not necessarily pushing the boundaries of language.
So they're playing it safe, following the established rules. What about SLMs? Are they the rule breakers?
In a sense, yes. SLMs, because they have less computational power and a simpler architecture, have to be more flexible and inventive with language. They can't just rely on brute force processing. They have to find these clever ways to convey meaning and intent.
So it's like they're forced to become more attuned to the nuances of language, how those subtle shifts in wording can have a big impact on meaning. Is that what leads to these more creative and effective instructions?
Exactly. And the paper provides some evidence for this. They look specifically at how SLMs and LLMs evolved instructions over time. They found that LLMs tend to make these incremental changes, adding or tweaking words within their existing frameworks, but the SLMs, they were much more likely to completely restructure instructions to experiment with new formats and approaches.
It's like LLMs are editing a rough draft while SLMs are tearing up the whole manuscript and starting fresh. No wonder they're coming up with more novel instructions. But this all sounds pretty theoretical. How does it actually play out in practice? Can you give me a concrete example of how an SLM might approach instruction creation differently than an LLM?
Absolutely. Let's go back to that idea of instruction tuning being like a recipe. Imagine you want to teach an LLM how to summarize factual topics for a young audience.
Okay, so we need to give it instructions on how to take complex information and make it simple and engaging for kids.
Right. A large language model, given this task, might come up with an instruction like, summarize the following text in 3 bullet points using simple language. Straightforward, but maybe a bit lacking in inspiration.
Yeah, it gets the job done, but it's not exactly exciting. What would an SLM do differently?
An SLM, given the same task, might come up with something like, imagine you're telling a fascinating story to your little brother. Explain this topic in a way that would make him want to learn more.
Okay, now that's definitely more engaging. It's not just about summarizing the information, it's about sparking curiosity and imagination. I can see how that kind of instruction would lead to a much richer and more effective output from the LLM.
Exactly. And that's the power of SLMs in instruction evolution. They're not just thinking about how to convey information, they're thinking about how to elicit a specific response, how to tap into the LLM's potential for creativity and insight.
This is all really fascinating, but I have to admit, it also raises some questions for me. If SLMs are so good at crafting instructions for other AI models, what about crafting instructions for us, for humans? Could this technology be used to personalize learning, to help us acquire new skills, or solve complex problems more effectively?
It's a really intriguing possibility, and the researchers do touch on this idea in the paper. They suggest that SLMs, because of their ability to tailor instructions to specific needs and contexts, could potentially be used to create personalized learning plans, interactive tutorials, even AI-powered brainstorming partners.
It's like having a custom-designed learning experience guided by an AI that understands your strengths, weaknesses, and learning style. That's pretty mind-blowing.
It definitely opens up a lot of exciting possibilities, but of course there are also challenges and considerations that need to be addressed.
Right, like ensuring that these AI-generated instructions are accurate, unbiased, and truly beneficial. And then there are those bigger questions. What does it mean to have AI shaping how we learn and think? Are we ceding too much control to algorithms?
Those are important questions to grapple with, and this research highlights the need for ongoing discussion and careful consideration of the ethical implications of AI.
This all ties back to that concept you mentioned earlier, the larger models paradox. The idea that bigger isn't always better, and that smaller, more specialized models might be the key to unlocking certain capabilities. It seems like this research is a perfect example of that paradox in action.
Absolutely. And it challenges us to think differently about AI development. Maybe instead of always striving for bigger and more complex models, we should also be focusing on creating more diverse and specialized AI systems, each designed to excel in a specific domain.
It's like building a diverse ecosystem of AI, each with its own unique strengths and contributions.
Exactly. And who knows, maybe these smaller, more agile models will hold the key to unlocking some of the most transformative applications of AI applications that we haven't even imagined yet.
Now, there was one other thing that caught my eye in this paper, and it's this new method the researchers developed for evaluating instructions. It's called Instruction Complex Aware IFD, or ICIFD for short. Can you tell us a bit more about that?
Sure. ICIFD is essentially a way to measure the effectiveness of an instruction set without actually having to train an LLM and see how it performs. It takes into account factors like the complexity of the instructions, the novelty of the language used, and how well the instructions align with the desired outcome.
So it's like a quality control check for instructions, a way to predict how well they'll work before you even start training the AI.
Exactly. And this is incredibly valuable because it saves a lot of time and computational resources. Traditionally, figuring out if your instructions were good or not involved a lot of trial and error running experiments, tweaking things until you got decent results.
But with ICIFD, you can get a pretty good idea up front if your instructions are likely to be effective.
Right. And this is especially important when you're dealing with very complex or specialized tasks where that larger model's paradox might come into play. If you're using an LLM for a task that might actually be better suited to a smaller model, ICIFD can help you identify that mismatch early on.
So it helps you choose the right tool for the job even before you start the project? That's pretty ingenious.
And it has the potential to really streamline that whole process of AI development, making it faster, more efficient, and more accessible.
This has been a truly insightful deep dive. We've covered so much ground. From the surprising power of smaller language models to the potential of AI-powered learning and the importance of considering ethical implications.
It's clear that this research is really challenging conventional wisdom about AI and opening up new frontiers in how we develop and apply this technology.
And for you listening in, it might have you thinking differently about the role of limitations, not just in AI, but in your own creative endeavors. Maybe those constraints aren't holding you back, but actually pushing you towards greater innovation and resourcefulness.
It's a powerful idea to ponder.
And on that note, we're going to take a quick pause. But don't go anywhere. When we come back, we'll wrap things up and leave you with some final thoughts to spark your own exploration of this fascinating field. And we're back for the final stretch of our deep dive into the world of smaller language models. You know, it's really fascinating stuff. We've been talking about this research that suggests smaller might actually be better when it comes to crafting instructions for LLMs.
Yeah, it definitely challenges some of those traditional assumptions about AI development, doesn't it?
It really does. We've been so focused on building bigger, more powerful AI that we've maybe overlooked the potential of these smaller, more specialized systems.
Right. It's like each type of language model has its own strengths and weaknesses, its own way of approaching language and solving problems.
It's like that saying, if all you have is a hammer, everything looks like a nail. And we need a whole toolbox of AI models if we want to effectively tackle the huge range of challenges we're facing.
Absolutely. And this research suggests that maybe SLM should be part of that toolbox.
Yeah.
They might not be able to write a novel or compose a symphony or anything, but when it comes to crafting those really precise and creative instructions, they seem to have a real knack for it.
Yeah. It's almost like they've mastered the art of communication, how to convey meaning and intent in a way that elicits a very specific response. And that's really what instruction tuning is all about, right? It's not just about giving the LLM information. It's about guiding its behavior, shaping its output.
It's about using language to influence these incredibly complex systems. And this research shows that maybe that's not always about sheer size and computational power.
It really makes you think about the role of constraints in creativity. I mean, we often see limitations as these obstacles, but maybe they can actually be catalysts for innovation.
It's a really intriguing idea. And it's not just limited to AI. Think about how many amazing works of art or literature or even scientific discoveries have come about from working within certain limitations.
Resourcefulness often thrives when we're forced to think outside the box. Who knows what kind of breakthroughs we could see if we embrace this idea in AI development?
Yeah, it opens up all sorts of possibilities. Maybe instead of always striving for those larger, more generalized models, we should be exploring a wider range of AI systems, each one tailored to a specific domain.
Like we're cultivating a garden of AI, each model flourishing in its own unique niche. But this all leads to another question. Where do we go from here? What are the next steps in exploring this whole potential of SLMs for instruction evolution?
Well, there's certainly a lot to explore. For one thing, we need to refine the techniques for training and evaluating these smaller models.
Yeah.
I mean, the ICIFD score that we talked about, that's a great start, but there's always room for improvement, right?
Yeah.
We also need to figure out how we can use SLMs to create instructions not just for other AI models, but for humans too.
Right. That's something we touched on earlier. Using AI to really personalize learning, to create those custom designed instructions for different individuals, is a really powerful concept. But we also have to be mindful of the ethical implications.
Absolutely. We have to proceed with caution. Like any powerful technology, we have to be responsible in how we develop and use it. But that doesn't mean we should shy away from exploring its potential.
And maybe one of the most important takeaways from this whole discussion is that it challenges some of our core assumptions about AI and about intelligence in general.
Yeah.
It's a good reminder that the most effective solutions, they aren't always the most complex or the most resource intensive.
Sometimes a little creative constraint can go a long way,
Huh.
and a deep understanding of how language works.
Well said. And on that note, we've come to the end of our deep dive for today. I hope you found it as fascinating as we did. And remember, keep asking questions, keep learning, and keep pushing the boundaries of what you thought possible in this incredible world of AI. You never know what amazing discoveries might be waiting just around the corner.